Yes, recording has been started. Let me share my screen and open the presentation.
So screen is visible. You can go ahead now.
Okay. Hello everyone. We are the students of Masters of Applied Computing at University of Windsor. And today we will present the web search engine, the final project for the Advanced Applied Computing course. And our instructor is Dr. Mehdi. My name is Nikhilesh, and with my team member Pallav, we will start presenting the presentation. So coming to the index of our presentation, it includes the definition, problem statement, product roadmap, concepts used, feature, flow diagrams, and ending with the live demo. So starting with the web search engine definition, a web search engine is a piece of a software that lets people find the information they are looking for online using the keywords or the phrases. The web search engine can retrieve the results quickly, despite the fact that there are millions of websites online, by continuously scanning the internet and indexing every page. The web search engine looks at the titles, keywords, and the contents, and also uses various algorithms to come up with a list of the sites based on the user search keyword and with the most relevant ones on the top. So let's discuss the web search engine working. The web crawler crawls for the keyword searched across the millions of the web pages. So the web crawler is also known as the spider internet bot, usually used by the web search engines, for example, Google, Yahoo, and various other web browsers. The web search engine indexes the data of the websites given by the web crawler and presents them as output. So you can see the image, it's showing the working of the web search engine.
So coming to our problem statement, we have to design a real-time system, which is our web search engine, using the concept covered in our advanced computing concept course. It should be developed using Java data structures and algorithms. So coming to our product roadmap, we have four important features for our web search engine, starting with the web crawler. Second one is the HTML to text. Third one is searching keyword. And the last one is ranking the pages.
So starting with the concepts used to develop the web search engine. So first one is the hashed data structure. Before starting the hashed data structure, I want to discuss with the data structure. What's the data structure? A data structure is a data organization, management, and storage format that enables efficient access and modification. Hashes are a type of a data structure that stores element in a more secular way. So hashes are the sets that uses the hashes to store the elements. So the idea behind using the hash data structures is to store the unique URLs. The second one is the JSOUP. So JSOUP is a Java library for working with the real world HTML. It provides a very convenient API for fetching the URLs and extracting and manipulating data using the best of HTML5 DOM methods and CSS selectors. The third one is the Bohemia algorithm. So the Bohemia algorithm is used to find the offset of a search keyword in a paragraph or in a file, and corresponds to that. It will also calculate the occurrence. So the Bohemia algorithm is used as the most efficient string searching algorithm.
So coming to our fourth point is our buffer reader and buffer writer. Both of them are classified as buffered IO streams. Buffer reader is a class in Java that reads text from a character input stream, and buffer writer on the other hand is a Java class that writes text to a character output stream. The last one is our sorting. Sorting means arranging it in a certain order, often in an array like data structures. Various ordering criteria can use like sorting number from least to greatest or vice versa. So coming to our first important feature, which is web crawler. So this component of application is used to browse the World Wide Web and create copy of visited sites for fast searching. It is also known as web spider and also used by web search engines like Google and Yahoo. We are using hash sets to save unique URLs. JSOUP, and which is an object used here to fetch content and pass them into documents. We are using buffer reader and writer to read and data from URL to respective HTML files.
So our second component and the second feature is HTML to the text converter. So this component of the application is used to read all the HTML files that is produced by the web crawler. The HTML parser delegator helps in passing the HTML data into the text files. We have also used the substring method to update the extension of the files from .html to .txt. The buffer writer is also used to write all the data to the respective txt files, which can be further used by this used to the search for the data. In overall, this component of the application converts the HTML files to txt files by passing the HTML data. The third one, and the most important one, is the searching the keyword. This component of the application is used to search the input keyword by the user in the txt files. The buffer reader first reads all the files present in the directory. Then, the Bohemia algorithm is used to find the offset of the searched keyword in all the files. And correspond to that, it will calculate the occurrence of that keyword. The Bohemia algorithms is used here as it is the most efficient string searching algorithm with the highest standard benchmark. It compares each character of the substring, or we can say that the keyword in the file. The worst case complexity of the same is big O of the pattern length, or we can say the keyword length into the data length that's present in the file.
So the last important feature of our web search engine is ranking of the pages. This component of application is used to rank the file based on occurrence of the search word. Files are sorted by converting hash table to the array list using array set using the entry set which have keys mapped with the values. Collections.sort method is used to sort the values and collection.reverse method is used to reverse the order of the elements.
So coming to the flow diagram of our application, we'll start and the web crawler will start crawling the URL and like store all the data in the URL into the .html files. Then we convert the HTML files to the text files. And after that, it will pop up to to ask the user for his choice. So if the users enter the choice 2, it will end the program, or we can say it will end the web search engine. And in case like if it chooses the choice 1, it will ask for the input keyword to be searched in all the files. So once the user entered the search word, if it's found in the text files, then the text files will be ranked as per the highest occurrence, and like it will again ask for the choice. And in case like if the search keyword is not found in any of the files, it will again just go back to the main choice menu. Now coming to the live demo, let me open the code.
So coming to the code, so this is our main class which is driver class of our search engine. So here we can see in our main class, we are first initializing our URL limit, which is the limit of web pages to be searched. Then scanner is used to scan the class objects. In the main, we are using this URL, which is youtube.com. Then we are using the webcrawler.crawl method, which is our first feature. So coming to our web crawler, so web crawler is used to browse the wide web and create the copy of visited URL for fast searching. So here we have imported the required libraries also. In our web crawler class, we have a hash set which is to check whether the web crawler had visited the URLs and to save the unique URLs. Coming to our crawl method, so first we are checking whether the URL count is less than the URL limit and also to check the URLs are present in the our hash sets or not. If they are not present, then we are adding them to our hash set and also we are calling the read URL method. So going to our read URL method, here we are using the buffer reader method to read the content from our URL data, and then we are calling the write URL method. So write URL method is used to write the data using buffer writer to the HTML file with the name of wiki info and with the integer index of the hash set. Going for going forward, so here we are using the jsoup.connect to establish a connection with the URL and also parsing the content into our documents. Here we are passing the content which contains the URL links as an parameter to our crawl method again.
So coming back to the main method, then we call HTML to the text, uh, HTML to the text converter method of the HTML to the text class. So let me open the HTML to the text.java class. So after importing all the required libraries, we have the HTML to the text converter method present in the class. Firstly, we define the path for the our HTML files, and we list out all the files present in that. Once we get each HTML file name, so we use the substring method to update update them into .txt files, and then we are using the file reader object to read the file, and then using the buffer writer, we are just uh, saving the file into .txt format. Going back to the main, then it will pop up with the options to the user to choice between the first and the second one. So if the user choice one, it will search the word in this given link, whereas the option two will close the program. So once the user selects the option one, it will ask for the user to enter the keyword to be searched, and then we'll call the word search method of the search class. So going to the search class, yeah. So after importing all the required libraries, we will just describe the path of our .txt, describe the path of our txt files directory, and getting all the files over from there. After getting each of the file name, we are using .readAll method to read all the data in the corresponding files, and then we are using the Bohemia algorithm to search for the offset and count the occurrence of the search keyword in the respective files. So once we got the search keyword in our file, then we call the ranking method of the rank pages. So let me open the rank pages class.
So coming to our last feature, which is ranking the pages. So we are using the rank pages here. So this class is used to rank the text file based on the occurrence of the search word. So here we can see we are using hash table which store the name of file as key, comma, and also the occurrence of the search word as value. Here we are using entry set to convert the hash table to array list and retaining the key and value pairs. So here we are using the rank file dot put method to add values to the hash table, and then coming to our ranking method. So first we are using the entry set method to convert the hash table to our array list, and then we are using the collection dot sort method to compare both objects of the array list, and then we are using the collection dot reverse method to reverse the order of an array with the highest occurrence, and at last we are printing the result from highest to the least with number of occurrence. Now going back to our main function, we will run our web search engine.
Let's run the code and see the output. So once the code is run, it will take few minutes, where the web crawler will crawl through all the links. So let's wait till that time. Yeah. Once the code is run, it will ask the user to enter two choice from one and two. So let's Select option 1 and enter keyword to be searched. As you see, it searched for the test keyword in all the respective files, and it returns the file name with the highest occurrence and followed by the least occurrence. So let's search one other word. Let's search for the YouTube, and we can see that it has searched for the YouTube word in the respective files. Now let's take one more example and search for any of the random word. Here we can see that it has given the result as a word not found, because this random word is not available in any of the files. So now let's exit the code, and now our web search engine is closed. So coming back to the code, we can see that we have followed the appropriate comments to improve the readability of the code. Now let's move to the folder structure, and
So
Pallav will
here,
explain the folder structure.
yeah. So here, this is our folder structure. If you see, we have a README text file. So this file is for the users who are not familiar with the codings. They can go through this README text file to understand the code and their process. Going to our source. So here we can see we have HTML file and text file that contains HTML files and the text files from our web search engine. And our web search engine folder contains the classes and our main code.
So going back to the presentation,
So here these are the references we used in our presentations, and this is our future scope of our web search engine, that is add GUI, which is graphical user interface to our application, implement the word suggestion feature, add multiple URLs to the application, and store the data in application database. Thank you everyone, and you can contact us on the mentioned emails for any further queries.
thank you.